Hello everyone. So today I'm here with you with a new topic, which is one of the Python library available. And I hope many of you ever faced such situation while dealing with the machine learning or the predictive modeling use cases. Like sometime it happens the client has given you very huge amount of data, and when we have a very limitation time to check it out, what kind of specific algorithms we can apply on that, and we are running behind the time to get it done within that certain duration of time. So lazy predict can help you out in that situation, which help us to create the to let you know that multiple machine learning models that you can apply on that, whether it's for the classification or for the regression. So I'll show you that how to use it, and what when we can use it, and when we should avoid using it. So first, that's the beauty of Python, that Python is a versatile language, but still we have so many packages available to deal with the different kind of the situations. So lazy predict, first we need to install. That's a package available. So pip install lazy predict is the command that you need to pass, and that is done. Installation is done. Once installation is done, then you can simply import it. So here I'll show you how to do it. For example, okay, this is something, just a moment. Yes. So there are several, the use cases where we quickly need to build a machine learning model, and so many algorithms are available, but we are still confused that for which algorithm we should go ahead. So what we can do, we can take a sample of the data and we can quickly apply lazy predict on that, and it will give you the accuracy or the responses out of each and every algorithms which is available there for regression or for the classification both. So first we need to check that at what situation we simply can apply lazy predict. Basically, uh, when we quickly want to explore the data which is available with us, not a very huge amount of data, sample data, you can sample, make a random sampling out of that data and create a certain amount of data to use it to apply a lazy predict, not to the entire data, because it got failed when you're applied a very huge amount of data that we actually deal in real time scenarios. So lazy predict can be used to quickly explore and analyze the data set by training and testing multiple models on the data, and it will give you the summary of each and every algorithm's performance. And lazy predict can also help you compare and select the best machine learning model by testing out and comparing the different performance metrics. Uh, you can quickly do our prototyping of machine learning models, uh, where we can quickly test the feasibility of the machine learning solution for the provided problem. That is the one case. Apart from this, there are so many students available, or they are learning the data science and all. They keep applying multiple machine learning or learning algorithms, and they need to check that how they are performing, which one is best to to continue further. So for the educational purpose, we can use it. And although I always recommend you to go to the in-depth understanding of a particular algorithm, but if you know that and you're running behind the time and you just need to quickly check it out how this particular data set we can use and which algorithm we can simply apply on this first. So this way you can save your time, that let's say it has given you multiple algorithms and in which you have the performance metrics available as well. So you pick the few of them, and then you can further fine tune to get the better result. So how we apply it, I will just let you know. So once we're done with installing the lazy predict, we first need to import it. Lazy predict classifier and regressor both are available. So this is just to import it. And if we need to use the lazy classifier, so we need to basically import it. So here it is. We are just going to import lazy classifier, and then the data set we are using is from their the sklearn data set library. we are loading the breast cancer data, which is for the classification, and we have parallelly imported the train test split method because we are going to split our data into training and testing samples. So I just imported it, and this one as well, and my data object is here, load breast cancer, and I have stored that in a data variable. So I just need to create my independent and target variables, which I have separated out here from data. From data, there is the data feature in which I have all the independent variables, and target is there, in which I'm going to store in Y. And then I'm going to split my data into 50% training and testing. It's up to you. You can increase and I will not recommend to decrease. You can increase accordingly. You can make a 60, 70, or it's up to you. And then I simply splitted the data set into training and testing samples. And then I'm going to apply the lazy classifiers, which I already imported. You must have seen here the lazy classifier we have imported from LazyPredict supervised. And here it is. And I have passed certain the parameters here and created a CLF object out of it. So once I will run it out of lazy classifier, the object that we have created here, in that object I'm going to fit my training and test data to get the model outcome and predictions which is available there. So in this line, I'm doing the same thing, clf.fit. That basically does in every machine learning algorithm. You create your algorithm object and fit the training and testing data to get the outcome from that algorithm. So exactly the same thing we did here. And once we run it, it will by default pick multiple, the algorithms out of there, and it will give you the accuracy, that what is the accuracy coming out of it. So here you see that multiple models it has created: LGBM classifier, Exploratory classifier, RIS classifier, AdaBoost, K-neighbors, Bernoulli, INB, linear discriminant, LDA, what we call it, Gaussian NB, so many decision tree classifier, dummy classifier, and it also gives you the time it has taken to to run the particular algorithm. So here you can see few have taken this much and few have taken much time. So that's what you can see from here. And from here, it's completely a dummy data. So obviously we're getting the accuracy 99, but this is not, this is something which actually don't happen in real-time scenarios. We hardly get 70 plus, which is a good achievement for us. So you see, and you simply pick few of the algorithms out there, and then you can further fine tune it and to get the to make it more better and to predict something better than this. So this is just to do a quick, kind of exploratory data analysis and all. You required so much time to do it, and then you have to prepare your data to apply algorithms that should be normalized, that should be labeled, something like that. So that's a quick job for you, which will save a lot of time for you. I have used one data set, my Titanic data set. Titanic data is the data which is I have taken from this. So let me import PD as well. Okay. So I'm going to import pandas as PD. So once I run it, there is the data. So let me show you the data first. So data looks like this. Underscore data dot head I can apply so that you can see that is labeled, and there is no unlabeled data available. So it's not the direct Titanic data which we have. So we majorly use it for a practice and academics and all. So exactly the same data I used, and I filtered out my independent and dependent variable out of it and created a train test split. And then the Titanic CLF object I have created using lazy classifier, and then I'm going to fit the Titanic train test data here to Titanic lazy classifier algorithms that I have extracted from there. So it will quickly do the job. And once you print the models, you see that it has chosen random forest classifier as the highest accuracy here. And ROC curve, F1 score, balanced accuracy. It has given some more performance metrics, for the evaluation of the model. So you can utilize. Although this is just for the understanding, you cannot be 100% sure that this is something that you can use it further, but you can get the idea out of here. Or maybe you can quickly, pitch to the client and let them know that what you could do. So these are certain algorithms you can pick, and this is from the random data. You have not done anything and you're getting something out of it, like that. So this is what we does for the uh, classifier. And now the same thing we can do for the regression, supervised regression as well. So the LazyPredict supervised, we have lazy regressor available. So we just imported out, and we have taken the Boston data set from the sklearn library itself to utilize it. And we created the training and testing data out of it, and sampling that you're doing is 90:10 ratio is here. So once you run it, again, you see that it will apply multiple regression algorithms on top of it, and you will be getting the output. So let it finish. This is done, and then you can print the models. So you see that we have a different performance outcome here. Previously, we were having the accuracy, which is balanced accuracy, ROC, AOC curve, and F1 score, which is the evaluation, performance evaluation metrics for the classification algorithms. And this is for the regression one. Like you see adjusted R squared, RMSE, root mean square error, that's what you call it, and the time taken for it. So you see that SVR, bagging regressor, and is the best one, and you see that a few algorithms, they are not performing quite well. It has given you the idea. So might be that you pick the data, you prepare it, and you start applying certain algorithms which is not performing well. So you may have the idea like from where you can start. So you can pick 4-5 algorithms to get like, and do a hit and trial where you're getting the output. Although LazyPredict is there, and you can use it for the multiple purpose that I have explained, that in case you need to do a quick prototyping and need to check which model you can apply, or a quick exploratory data analysis that you do not have time to do. So you can use LazyPredict in that case to, to get a summary of, to test multiple models on top of that data and get the summary out of it. And you can use it for educational purpose as well. But there are certain cases that LazyPredict is not suitable. When we are dealing with the actual scenarios, we have to deal, data is the main problem there, that we have very huge amount of data. So to that large amount of data sets, we cannot use LazyPredict. It is not efficient to use it on that, because it will become computationally expensive, because by default it is applying so many algorithms available. So you see, if we apply one algorithm, still that take a much time. But if you're applying all the algorithms all together, so that can be computationally quite expensive. So to the large data sets, we should avoid it. What we can do in that scenario, you just sample the data out of that big data. So then you can apply, right? And the custom models that for example, if you need to do certain customization on your model, you need to or maybe you want to implement it manually. People are doing that. So in that case also, LazyPredict is not recommended. And in case you want to fine tune your model further, so what LazyPredict does, it does not allow you to fine tune and all. It do everything by own self. We do not have a scope to do it. You just get the idea and then pick those algorithms and then fine tune it. So this is how you can utilize LazyPredict. So that's it for that. So I hope you get the idea at what situation we use it, at what situation we cannot use it. If you have any queries, feel free to connect. So that's it for today. Thank you very much. Take care. Bye-bye.